Hello, welcome to chapter 18. We are going to be talking about conservation and biodiversity in this chapter. So go ahead and tuck in and we'll start taking notes. So biodiversity is going to be defined as a variety of genes, species, and ecosystems on Earth. So it's a pretty big definition of what we classify as biodiversity. So it can be something as small as different genes, or we can be talking about different species in an environment. Think about maybe we were looking at like a ecosystem as far as a community of starfish and fish and urchins and clams and things. So different species. We can also look at different species maybe even smaller than that. So ecosystems can be even smaller, like living on our skin or living in our gut. It just kind of depends. So we can look at all kinds of biodiversity in all kinds of aspects. Now, when it comes to biodiversity and the value that it holds, we typically are going to view that from the perspective of what is the value of this diversity to humans? Now, biodiversity on the planet does serve a value within the planet itself, outside of the perspective of humans. So let's talk about that. When we talk about the value of biodiversity within an ecosystem that has nothing to do with humans. We call this an intrinsic value. This is the inherent value of biodiversity independent of its value to humans. When it comes to extrinsic or utilitarian value, this is where we throw people into the mix. What is the value of that biodiversity specifically to our species? So we can classify this into essentially 4 categories, and let's talk about what goes into each category. So the value of biodiversity to humans for provisioning services, this is probably the one you think of maybe the most, is going to be food, raw materials, fresh water, as well as medicines. That's kind of the big one. Then we have regulating services when it comes to biodiversity. This is going to be the natural world kind of creating quality air, water, and soil, which is important to us because if we can't breathe and there's not clean water and, soil for farming and agriculture and things like that, then we will be affected. Then we can talk about carbon storage and climate regulation, pollination, and biological control, all of which are going to have very strong importances to us, right? Then we have habitat services. This is habitats for species and maintenance of genetic diversity. You might not immediately think, well, that is going to affect us, but it does. If those environments collapse, it will affect us. If we affect an environment by pulling too much of one species, or a certain species is causing problems in an environment, that can affect people in that area, depending on what we're talking about. For example, like snakes in Hawaii, that affects the local bird population, which I believe quite a few birds in Hawaii are very big in the pollinating services, essentially in those islands. And so by affecting those birds, you're affecting the pollination, and thus you're going to affect crops. So big thing there. And then the last one, again, not necessarily the one you think of first, but you probably do hold a lot of value to cultural services. These are the natural aesthetics and inspiration or recreation and mental health that come with being in a natural area. If you've ever been to a national park, or maybe like something like the Grand Canyon or Yellowstone or the Grand Tetons or Glacier National Park. They're breathtaking. They're absolutely stunning places to visit, and keeping those environments in working order, essentially, so that we can enjoy it. That is the value that we hold to that particular service. That also kind of goes hand in hand with tourism in a spiritual experience. So let's talk about preserving these natural resources and making it to where future generations can enjoy the earth as much as possible. When we talk about this type of field of study, it is called conservation biology. It is going to address how to understand and preserve the natural biological resources of Earth, including all levels of biodiversity. And again, this is to serve the purpose of future, not just present, but for the future. How can we keep things clean and safe for those future generations? As well as just years and years down the line, how do we keep Earth's natural resources available? Now, we've talked a little bit about this before, but let's address it again. So, where on Earth do we see the greatest biodiversity? And that is going to be around the equator. And as we move away from the equator, more north or more south, we are going to have less biodiversity. And it has everything to do with where that solar energy is going to hit the Earth. Now, I know we talked about this before, and I'm going to reiterate that this is very important to remember because it might be a short answer. But where we have the greatest biodiversity and why is going to be the equator, and it has everything to do with that solar energy. Which, remember, when it comes to solar energy, that is that starting point of energy in any environment. And that is going to go into our plants, which is going to convert that light into energy, consumable energy, and then it's going to move its way through the food chain. So we've got two important things to talk about on this slide. The first is this term species richness. This is going to be the number of species within an area. So if an environment is particularly rich, that means there are many species living in that area. Now, what can affect species richness and biodiversity in general? Because if we're talking about species richness, we're saying that there is a higher biodiversity in that location, right? So there are factors that affect that species richness or how high or low that biodiversity in an area is. The big one that we were just talking about is going to be available solar energy. So near the equator, where the solar energy is going to directly hit the planet, is going to have the greatest access to solar energy, which is that base fuel for all of life. Now, as we move away from the equator, where that sun is directly hitting, or that solar energy is directly hitting, you get less solar energy being available, and so that species richness is going to decrease as you move away from the equator. We can also look at evolutionary history of an area. So if communities diversify over time, the more time that passes without a climatic event, such as an ice age or something like that, then the greater the diversity in the area will be. So if there is less of a mass disruption, something again like an ice age, or maybe a meteor hitting in a certain area, then you are going to see that biodiversity have time to continue to diversify, and we increase in that species richness. And then the last is rate of disturbance. So if a habitat has a higher rate of disturbances, like forest fires are more common in those areas, then they tend to have kind of a intermediate species richness. Let me explain. So you don't want a ton of forest fires. You don't want no forest fires. A handful of disturbances is actually going to be that sweet spot when it comes to species richness in an area. Because sometimes fires or floods, it just kind of depends on what we're talking about, what type of environment, but let's go with fires. Sometimes fires are necessary when it comes to biodiversity and as well as life just in general. Fire or heat can open up seeds in certain areas if that is an area that is a little bit more prone to forest fires. So sometimes that's a good thing and will help with the biodiversity in that area. All right, guys, there are roughly 25 biodiversity hotspots. These are what we call reservoirs of biodiversity on the planet. You'll notice that the vast majority of them are going to fall along that equator. I mean, they're not in a perfect line, and they're mostly along the coast, but we do have these biodiversity hotspots, things like tropical rainforest and islands like Madagascar or the coral reefs. These are areas that have an extreme amount of biodiversity. And the unfortunate thing, guys, is that all of them are under threat, especially around the equator there, where we have quite a few trees and various trees that are in high demand. We'll talk about that a little bit later here. But they're going to be areas that have a very high value to humans. And unfortunately, that means those resources get removed and disrupt a lot of these reservoirs of biodiversity. So very important to keep safe because they are in constant threat. Now, I know we've talked about extinction before, but let's dive a little deeper and keep talking about that. And this will play a pretty big role in why we need to take care of the biodiversity on this planet. Because once a species is gone, they're gone. We can't bring them back. And now I know in the current moment, which is spring of 2025, we do have dire wolves being produced, if you have not heard. However, they are not true dire wolves, and in fact, they are mainly gray wolves that have a very small but a higher percentage of dire wolf DNA that has been modified in gray wolf DNA to make these dire wolves. But again, it'd be like saying that in a human who has more Neanderthal DNA that we've brought Neanderthals back. Well, we haven't. You're just a human who has more Neanderthal DNA. These are gray wolves that have more dire wolf DNA than they did before. But that's through modification of their genome. When it comes to natural extinctions, they do happen. Remember, we called them background extinctions. And on average, the expiration date for most species is roughly 10 million years. There are a handful of species that go well past that. You guys know that my favorite animal is a jellyfish. And jellyfish as a species in general are roughly 500 million years old. They have reached that expiration date and then some, which is kind of neat, but some species are just really good at surviving. Other species, there is that natural expiration date. However, remember, it always comes back to the rate of extinction. And if we have a higher rate of animals or plants or fungi or whatever going extinct at within a shorter period of time, that is called a mass extinction, instead of just those background extinctions where we see species meeting that natural expiration date. One of the examples I have here is the passenger pigeon. They went extinct, I believe, in the 1900s. The last known passenger pigeon was named Martha, and I do believe this is a picture of Martha. She is taxidermied, but she was living in the Cincinnati Zoo, and unfortunately, she was the last of her kind because humans hunted them into extinction, which is very unfortunate. A handful more of species that have gone extinct that I would like you to know is this particular river dolphin, a Baji dolphin, went extinct in 2007. We have a quagga, which was kind of in appearance, looked like a zebra and a horse, but it was not. It was its own species. It was not a hybrid. The last one that existed was in a zoo. You'll notice a lot of these. The last one that existed was either in a zoo or a reserve of some kind. The quagga went extinct in a zoo in 1872. We talked about Lonesome George before, but there's a picture of him. He's a Pinta Island tortoise, and he was the last of his kind in 2012. There were a lot of very valiant efforts to try to get him to mate with another tortoise species that was very close to the Pinta Island tortoise. And unfortunately, all of those attempts failed because he'd never seen another Pinta Island tortoise before, or another tortoise like him, and so he didn't really know what to do, unfortunately. So Lonesome George was the last of his species. We have the splendid poison frog. The last time that this frog was seen was sometime in 2020, or a little bit before that, and since then they have not found any more of these really adorable frogs, and they were listed as being extinct. Now, that kind of brings up a good point here, that when it comes to this statement, this species is extinct, it's because we don't see them on the planet. We can't find them anymore. So that is what gives us that notion that all of that species is gone. We also have the Tasmanian tiger, also the last of his kind of the reverse of that quagga, interesting enough. The last of that species died in a zoo, I believe in New Zealand, in 1936. And then very recently, in 2024, we have this very sweet looking fruit bat, the little Mariana fruit bat. The last one that was seen was sometime in 2023, and by 2024 it was pronounced extinct. Just to reiterate, those two types of extinction, we have mass extinction and background extinctions. Those background extinctions are going to be those more natural expiration dates that are constantly happening when a species kind of reaches that limit of roughly 10 million years and then dies out in some capacity. However, again, some species persist long after that natural expiration date that we typically see. But that does happen. Again, it has to do with the rate and then within the amount of time. How many species are dying within a shorter period of time? With mass extinctions, we see a spike of a ton of species going extinct all at once. And we've had 5 mass extinctions. However, we are seeing an unprecedented rate of extinction caused by humans, which is mostly having to do with habitat destruction, but we'll talk about a few other things that are causing a lot of issues with the planet through this chapter. there are certain aspects that can affect the risk of a species going extinct, and this is more like what can cause that natural extinction, that background extinction. The first factor is going to be geographic range. So if a species has a very extensive range that it can live in, then they'll be less vulnerable. However, if a species is restricted to a single little island off of maybe Australia, I believe that's Tasmania, then that is a very vulnerable species because you have nowhere else to go. You're not found anywhere else as a species. If something happens in that environment, then you are gone as a species, and it has to do with that geographic range. The next factor that can influence the risk of background extinction is the local population size. If you have a hefty population size, you are particularly rich in your population density, then you're probably going to do fine. If, a hawk or something comes along and takes away Barbara over there, well, no biggie. There's a ton of others of your species left to breed with and make more of that particular species. Versus if you have a small species, a small amount of your species left, where it's just, you and Barbara only, and Barbara gets carried off by a hawk, well, now you have a Lonesome George situation, and you are the only one left. So that is going to play very strongly into that risk of going extinct as a species if you have a small population size versus if you have a very safe, larger population size. And then habitat tolerance. That's going to be the last factor when it comes to extinction. Now, I like to think of this as being more picky as a species. If you are not picky at all about where you can exist within your habitat, maybe where you can breed or build a nest or where you live, whatever, in your habitat, you are not picky. You could live on that twig, you could live on the top of the tree, you could live on the ground. You're not picky at all. So if something happens to the twig, then you have two other options. However, if you have a more narrow habitat tolerance and you're very picky as a species, and the only place that you will build a nest is on that twig, nowhere else is an option, then if something happens to where that twig is not available, or it becomes unavailable through maybe habitat destruction, something like that, well, your species is going to go extinct because that is too picky to survive as a species. Now, I mentioned this before. Currently, we are in the midst of a mass extinction, and let's talk about how we know that. 10%, or more than 10% of mammals are endangered, and roughly 21% are endangered or threatened. A lot of you chose a lot of mammals for your Save the Species project, and you know this in your research, that there are a lot of reasons as well as a lot of species that you could have chose from for species that are endangered or threatened, or maybe they're at risk. It just depends. 4% of bird species are endangered, 13% are endangered or threatened, 50% are in decline, which is crazy. A third of amphibian species are endangered or threatened, and situations are similarly dire for fish, mollusks, insects, fungi, and plants. So pretty much they're are very few species on the planet that are actually safe. Let's talk about what's happening to them. All right, it's us. Big surprise. It is human activity causing this current sixth mass extinction. And a lot of it has to do with habitat loss and degradation. And this is going to be caused because we want to develop areas for people to live, as well as develop areas to make food for the very massive amount of people that live on this planet. So normally, if we were in class, I would ask you all to raise your hand if you were less than 25 years of age, because in your lifetime, half of the world's tropical forests have been destroyed. And once it's gone, guys, it's gone. It's not coming back. We cannot get it to come back, at least not the way that it was. Can we go plant trees? Sure. But these areas of massive biodiversity have now been irreparably disrupted. That is very important to remember through all of this, that once it's gone and it's going to be changed forever, and usually to the detriment of that environment. Now, it's not just the rainforests that are being destroyed, it is habitats everywhere, worldwide. So you guys know that one of my favorite places in the US is the Pacific Northwest. I've talked about Washington and Oregon quite a few times and how much I adore it. And unfortunately, kind of in our own backyard, we are seeing the Pacific Northwest being logged to the point that it is incredibly unsustainable. We cannot keep up with this rate of removing trees from these areas. The forest cannot recover in time, because think of it this way. It takes years, possibly hundreds of years, for those forests to develop the way that they have, and it takes us a couple of days to tear it down. That rate is insane. There are also big concerns when it comes to overexploiting these habitats, destroying them, and what it does to the local populations of species. For example, bonobos, and I don't want to say too much about them, as some of you have chosen the bonobo as your Save the Species project species. But bonobos are kind of adjacent to a chimpanzee, except where chimpanzees actively have wars amongst their tribes, bonobos make love and peace, which is kind of interesting. And there is an obscenely small amount of bonobos left due to this unsustainable removal of their habitat. So we will likely, very unfortunately, in our lifetime potentially see this species that is essentially a cousin to us go extinct because we have destroyed their home. And you might say, well, can't they live in a reserve or in zoos? Bonobos do not do well in captivity at all, and they have a tendency to die within captivity. Very unfortunate. Now, it's not all doom and gloom, but we still need to be realistic. Some ecosystem disturbances can be reversed. Things can come back. Abandoned agricultural areas do have a tendency to transition back to a forest, but the problem here, guys, is time. It's the amount of time that it takes for those areas to actually go back to the way that they either were or to something new that is sustainable to that environment. There are many examples of ecosystem disturbances that are not reversible. a great example is anytime we talk about extinction. Again, extinction is permanent. I know, again, the dire wolves, they're back. They're not. Something like bringing back the woolly mammoth. I don't think that's entirely possible. But hey, I could be proven wrong. But just know, not most species will not be brought back from the grave once they have gone extinct. Once they're gone, they're gone. Now, not all ecosystem disturbances are going to be man-made. Some of them are perfectly natural. Think about Mount St. Helens. Once again, we're in the Pacific Northwest. I have visited Mount St. Helens a few years ago, and it is stunning. I highly recommend visiting if you get the chance. This was a volcano that erupted back in the 1980s. I think it was 1980s, but yep, no, it's on the slide, Rachel. You can read. In 1980, the mountain essentially exploded. And what's interesting is that today, yes, the environment has been drastically changed from that explosion, but we've got nearly 40 going on 50 years since Mount St. Helens erupted. And while it's not what it was, it is something new and it's coming back. So this is a reversible disturbance. But again, guys, it all has to do with time. Time is not always our friend, especially when it comes to species that need to exist in these areas to survive. 50 years is an incredibly long amount of time to wait for that environment to come back. But slowly but surely it is, which is our glimmer of hope. That's our silver lining. Ecosystems can come back after disturbances. It just takes time. As I said, however, some disturbances can't be reversed. Extinction is one of them. Once they're gone, they're gone. I gave you a couple examples before. Here's a few more. And then through your project, your Save the Species project, I want you to connect and understand that that species that you are writing about, that is a species that is potentially on the brink of this irreversible disturbance. They can't be brought back. Once they're gone, they are gone. So I want you to feel that and to care and to really let the rest of the class know how much we should care about your species and try to save it. So that's the big thing here, guys. Big thing we're trying to get across. Now, I refuse to let this chapter be nothing but doom and gloom and trying to guilt trip you into feeling like existing is impossible. So, what can you do? Well, some of it's a little bit above our pay grade, but things like the Paris Agreement exist for the purpose of that conservation of the earth. It is the attempt at trying to get multiple countries on board with saving the planet and saving species and habitats. So very important. There are a handful of other programs that do this. Things that you can personally do, something a little bit more maybe our pace, is volunteering your time. I do have a link there to the World Wildlife Fund, which many of you have written into your papers as being your organization, which I love. It's a fabulous one. But you can volunteer your time to help the earth, which is super cool. There are also tons of conservation programs and reserves all around our general area that you could volunteer at if you feel so inclined. You can also support conservation efforts via donations, which is precisely what we're going to do essentially as a class. We'll vote for our species within the class that you feel needs the most help, that you are convinced needs our support, and then I will donate on behalf of our class for that winning species to the organization of the author's choice. So we are going to make a difference this semester, guys. That is what we are going to do, but you can also do it too, on your own time. Another way that humans are damaging the environment is by introducing species that are not native to those ecosystems. So what we call a species that is either intentionally or accidentally brought into an area that it is not native to is an exotic species or an introduced species. They mean the same thing. Within this group of exotic species or introduced species, you can have invasive species. Now, not all introduced species are invasive, but all invasive species are introduced. Invasive species are going to be species that are not native to an area, so exotic species, except they are harmful to that ecosystem or they are harmful to the native species within that environment. Now, there are two characteristics that identify introduced species, and kind of more specifically invasive species. And it doesn't matter if it's an intentional or unintentional introduction, these two characteristics fit pretty well no matter what. But the exotic species will have potentially no predators or pathogens that will affect it in this new environment. So it's kind of like starting over in a new city or a new town or at a new school. It's a clean slate. No one knows who you are, and that kind of means that you, as that species, have a lot of benefits to that situation, especially if you're like a predator species, then you are likely now the new top predator because there's nothing there to kill you, make you prey, and also the new pathogens that maybe you bring with you could be a problem, or the pathogens in that area may not affect you the way that they affect the native species. It just depends. The second characteristic of an invasive species is that native plants and animals have no defense against that invasive exotic species. Now, we can think of something like cats being introduced to New Zealand for this character. When cats were introduced intentionally in New Zealand, and I mean like house cats, not like lions or anything like that. They're just normal house cats. There were no predators in New Zealand, and therefore cats became the top predator of everything living in New Zealand, which was essentially just like a ton of bird species, reptiles and amphibians, some insects as well. So because the native species had never seen a predator like that before, they had no defenses against cats in any way. So the cats went wild, and that is typically what we see when it comes to invasive species in these new habitats, that they're able to flourish essentially almost unchecked. I do want you to know a handful of the examples that we're going to go through here, and then there's another one on the next slide. But the difference between the examples on this slide and the one on the next is whether the introduction of this harmful introduced species, this invasive species, is accidental or on purpose. So let's talk about the accidental introduction of brown tree snakes to the island of Guam. Not dissimilar to what I was just talking about with New Zealand and cats, But there were no snakes on this island. And being a predator, this brown tree snake was essentially very successful at consuming the native bird species, and almost eradicated them, actually, which was kind of terrifying. But it's because those birds had never seen a snake before and had no natural defense mechanism to evade predation. So, very important to note that example. Very good example. Another accidental introduction is the purple loosestrife, which is, I'll be real, I think a lot of people confuse this for lavender, because it kind of looks a little like lavender, but it's not. It's purple loosestrife, but it was accidentally introduced into U.S. gardens as a garden plant, but that was again an accidental introduction. And the problem is it outcompetes the native species in the area, and usually these are like wetlands. So what we see is not dissimilar to how honeysuckle, which, fun fact, another invasive species, but that was purposefully brought over and planted in gardens because people thought it was pretty and it smelled good. The problem is it's very good at growing and spreading, and it chokes out other plant life, making it to where the only thing that can live in that general area is honeysuckle. Loosestrife also does this. Not a good time. Our last accidental introduction of an invasive species example is zebra mussels. And these are kind of like clams, where they were introduced to the Great Lakes in the US. Now, the way that they were introduced was these mussels were clinging to the bottom of a boat that had been in an area where the zebra mussels were native to, I'm assuming, or at least in, and then the boat was put into the Great Lakes, and then the mussels detached, and because it's a new area, they're the new kid on the block, they had all the advantages in the world. Now, they cause tons of problems from out-resourcing the local fish, eliminating food supplies, as well as causing problems for us by clogging water intake pipes, which is what we're seeing in that image there. That is a pipe cut open and absolutely full to bursting with zebra mussels. So these are accidental introduction examples of invasive species. Let's talk about a very wild, purposeful introduction next. All right, let me paint you a picture. In Australia, one of the crops that they grow, not dissimilar to in many countries, is sugarcane. And when it comes to sugarcane, there are multiple pests, but one that is in Australia that is particularly a big issue is the cane beetle. And the cane beetles do cause a lot of issues when it comes to the sugarcane itself. They consume the sugarcane and they're kind of a big issue. I don't know that pesticides work very well on them, and whatever the case may be, the local government or the government of Australia up and decided, well, gee, maybe we need to do something about this and try to get these cane beetles under control. So, somewhere around the world, I'll be real, I think it was Africa, I could be wrong, you don't have to know this, but in another country they have these toads. And the government of Australia was like, oh, dang, sign us up for some of those guys. I bet they would take care of our problem. These toads would be fabulous at consuming the cane beetles. Now, I'm assuming that they probably put a cane beetle in front of a toad and said, you want it? And then the cane toad ate the beetle. Now, that's great and everything, but when they actually brought over a pretty decent sized population of cane toads to Australia with the purpose of eradicating this pest species of beetle, the problem that happened was that the toad didn't eat the beetles. They ate everything else, from snakes to lizards to birds to crocodiles to small mammals even. They ate everything but the cane beetle. So these cane toads, as they have been come to be named, are pretty large. We can see this young lady holding a cane toad. He's the size of a pretty decent sized dinner plate. So they're pretty big. They're pretty big. They're predators. They're carnivores, and they reproduce in pretty large numbers as well. Now you might be thinking, oh, Australia though, Rachel. It's Australia. There's tons of things that eat everything in Australia. You are correct. That is a fact. However, cane toads are poisonous. They have poison glands and they cannot be consumed. So they can't be consumed by people. And then the native species have learned not to eat these toads because they're poisonous. So that is their defense. So they are a prime example of an invasive species that really has just run wild within this environment. Now, I think that this is a pretty prime example too of kind of messing around and finding out. Instead of doing a lot more research before introducing all these cane toads and then causing a much bigger problem, the government just kind of let this happen, and now Australia has this big problem of this invasive species. So what can you do? Well, you can plant local vegetation in your yard or garden. You can avoid the zebra mussel issue by, if you are someone who likes to use a boat, making sure you clean the outside of your boat really well before moving to a different body of water. If you like to hike, very important thing is to clean your boots before you go into a new natural area. So if you're like big into traveling through like the national parks, they may, and I know quite a few actually have this, have places where you can brush your boots off before you walk into the park. If you like to go camping into different areas, don't pack a pest by taking fruits and vegetables, maybe firewood. Make sure that you are not carrying a little hitchhiker with you into those areas and accidentally introduce a exotic species to an area that it didn't reside prior to that. One of the biggest ones, guys, and this is so silly to even have to say, but don't let your pets loose. Sounds weird, but like, don't think you're doing your aquarium fish a favor by releasing them into a local body of water or into like a river or something. They're exotic species. So don't do that, or like don't release your hamster or something out into the wild because he deserves a better life. Don't do that. And then something that you could do that's very active is, again, volunteering is great. So potentially a local park or a refuge, wildlife areas to help remove invasive species. I know there's a lot of places that will encourage you to remove things like honeysuckle, as it is such a intense invasive species that really does just choke out the natural plant wildlife, and it's not a good time. So volunteering your time is a great way to prevent invasive species from taking over and ruining areas. Another way that human activity damages the environment is through something called acid rain. This occurs as we burn fossil fuels. The way that things go is up, and as the saying goes, what goes up must comes down. So when we burn fossil fuels, they go into the atmosphere, where we then have that process of rain forming, and we talked about that in the last chapter. And then when the rain does come eventually, that mixture of fossil fuels that we have released into the atmosphere mix with water vapor and then falls back down to Earth. Big issue with acid rain or acid precipitation in general, because it's not just rain. We can see that acid fog is also an issue. I haven't heard of it before, but I'm sure that there is problems when it comes to snow as well. So I cannot reiterate this enough right now. Even consuming clean snow is not clean snow, and it has to do with this acid precipitation. It's never clean enough, I'll be real with you. So what can happen is the continual exposure to this acid water coming from the sky, or whatever, can kill plants and especially affect aquatic animals directly. So indirectly it can affect the soil and potential water chemistry. So this is kind of a neat map where we can see the acid rain distribution based on pH in the rain. Which, remember that when it comes to the pH scale, as you get closer to 1, you are getting more acidic. So we are seeing more on the East Coast, a stronger acidity than we are more to the west. And that may have more to do with fossil fuel burning, maybe population density. There's a handful of things, as well as potentially out west we have more trees, so potentially that is cleaning the air a little bit better. It just kind of depends. There's a lot of factors that go into this, but this is in general the pattern, that distribution that we are seeing of acid precipitation. These are the direct effects of acid fog, actually. So it's this direct contact with this acidic water to living tissue of these trees. So this water that has a stronger acidity is going to basically strip away the outside of the trees, potentially the leaves. And once you do that, you've essentially killed the tree, which is kind of terrible. So this, again, acid precipitation is not just rain. It will also affect fog, which, again, fog just kind of settles in areas. And that constant exposure to that acidic fog is going to strip away the living tissue on the outside of the tree. Here are some indirect effects of acid precipitation. So potentially the acid rain can leach essential ions from the soil, which is going to affect plant growth. It can leach ions, or leached ions are washed into lakes and streams. This can affect aquatic life. Dissolved ions increase the acidity of lakes and streams, again affecting aquatic wildlife. And some dissolved ions are directly toxic to animals specifically. Okay, what can you do? Well, they're more so things that you should probably do anyway, but maybe you don't think about it in the sense of, I'm doing this because I care about the planet. Maybe you think, I'm doing this because I care about my electric bill. But you can care about both of those things at the same time. You don't have to pick one or the other. They're both good reasons to do a lot of the things on this list. turn off your lights when you're not using them, turn off your computer, your television, video games, other electrical equipment when you are not using them. You can also unplug these items if you're not using them, because if it's plugged in, then electricity is going to be running to it. So I know that sounds kind of weird because yes, there's always electricity running to your house, but if you have like a cord plugged in, even if something's not necessarily on, you still have electric current going through that cord to that item. This is one that's kind of easier said than done, but buying equipment that uses less electricity, usually these items are more expensive. So things like lighting or air conditioners or heaters, refrigerators, washing machines that are a little bit more conservative on electricity, again, they're more expensive. So if you can do it, fabulous, great. Make those choices if you can. If you can't, unplug stuff, make sure things are turned off. Try to limit your use of air conditioning, and I know we're in the Midwest, guys. It can get freaking hot. So just be conscientious of your usage of your AC is a very decent and valiant effort, I think. And then one that kind of makes sense, and if you can do it, fabulous. If you can't, consider doing it maybe once or twice a month. Even small changes, they add up. But carpooling or taking public transportation, like a bus or a train, that is a great way to limit that fossil fuels from being burned. So again, small changes add up. That's a big thing here, guys. The next way that we are ruining the planet is through greenhouse gases. So you've probably talked about this in a previous class, maybe in like earth science or different science classes, who knows. Maybe in your younger years in elementary school, but it's been a hot topic for a very long time, is kind of what I'm saying here. So it's been around for a while, this concept of the greenhouse gas effect. So this is essentially a way that the gases that we have been emitting as a species, both industrially and agriculturally and through transportation, things like that, they are causing, through means that we'll talk about on the next slide, the average temperature of the planet to increase. Now, the thing I want to get across here is that the temperature of the planet fluctuates constantly. There's cold, then hot, then really hot, and then cold, and then really cold, and it cycles. It's cyclical. The problem is that the rate at which we have been increasing the temperature of the planet is the issue. It's getting too hot too quickly. Normally, the temperature rises at a lower rate. So it takes a lot more time to get to the temperatures we've been currently getting at. But we can see that we are the cause of the temperature of the planet, on average, getting hotter. So here is that greenhouse effect. We've got solar energy from the sun hitting the planet, and then once it's in our atmosphere, it hits the Earth's surface and then reflects off, bounces off. Now, normally that heat would then jump off the planet and get reflected off of the planet, essentially. However, because of our atmosphere changing because of these greenhouse gases. So different things like carbon emissions, carbon dioxide, methane, to name a few. It's basically creating like a seal around the Earth within the atmosphere, so that the vast majority of this heat that would have just reflected off and gone back out into space gets trapped on our planet. So it hits the atmosphere and it basically just comes back down and creates this like heated effect. We are essentially steaming ourselves in a way. Why is this a problem? Well, there's a few reasons why we don't want the planet to heat up this fast. One of them is because the ice caps are melting. We have an image of 1979. Now we have an image from 2016. I know that's coming up on nearly 10 years ago, maybe more, depending on when you're watching this video. But what we are seeing is that the areas that are supposed to be cold, supposed to be ice, areas that are covered in ice, maybe have glaciers, are melting at unprecedented rates. And those rates keep increasing. Again, it's cyclical that the planet goes through heating and cooling spells. However, it is happening at such an accelerated rate that this is not normal. This is not a normal way for our planet to heat or cool. Now, some more ways that the planet changing in temperature is a problem is that trees and flowers will bloom earlier at northern latitudes because they're going to be warmer. Migratory birds are going to arrive at summer ranges earlier again because it's warmer. Birds and butterflies are expanding geographic ranges northward because it's too hot, getting closer to the equator. And then the Arctic ice is thinning and melting. And for those of you who have chosen Arctic animals in your Save the Species project, you know that this is a huge problem because when the ice thins to the point that, like, say, polar bears cannot travel to where they would normally go to eat. If that ice is too thin and they have to swim, then that swimming depletes their fat reserves, and then if the ice is too thin, they have no place to consume maybe seals or things like that, maybe fish or whatever it is that they catch. So we see animals like polar bears starving to death because their natural habitats are being destroyed by just melting, which is crazy, guys. Absolutely insane. Devastating. Now, I would be remiss if we didn't start talking about malaria again. We've talked about malaria, I don't know, maybe 4 or 5 times in this class. You thought it was over. It was not. Now, why am I talking about malaria? Well, when it comes to the temperatures increasing, that means that species of mosquitoes that carry malaria can now start moving more north, like into the US. Now, currently in the US, that species of mosquito does not exist. It is more south that we see these mosquitoes that can carry malaria. Well, if the temperature rises, this species can then start moving more north because they can live within that heat range, which is kind of terrifying to think about. We can also see issues with ticks, which are these little bloodsuckers that can carry diseases of various kinds, from valley fever to Lyme disease, all kinds of stuff. But these guys can start expanding and changing their ranges and spreading those diseases as well. So what can you do? You can start talking to people about climate change and, just tell them exactly what I've been telling you guys. That yes, climate change is cyclical, but the rate at which the climate is changing right now is completely man-made. We have created this problem and we are the ones that need to try to fix it. Putting it off onto another generation is what previous generations have done, And obviously that didn't work. We are still seeing that problem. We have to solve the problem. We have to fix it. So talking to state representatives and trying to push the government to do the right thing. So that future generations can keep enjoying this planet and the various things that we've been able to, for the most part, enjoy. Look at renewable energy and things that go into essentially your electric bill. So trying to support renewable energy sources, weatherizing your house so that you have a more efficient heating and cooling system. And we talked about this in the last What Can You Do? Investing in energy efficient appliances, reduce your water waste, eat what you buy. And I'll be real, I am a huge offender of this. I have a tendency to, if I don't see it, I forget it exists. So I buy raspberries or something and then it gets pushed to the back behind the milk. I forget it's there. And then by the time I see it again, it's got its own little ecosystem growing inside of the container, but try not to do that. Be better than me, right? So eat what you buy, compost what you can't. LED light bulbs are a great way to save energy, unplug your electronics or turn them off when you are done using them or when they're done being charged. Try to be fuel conscious or conscious, that's the word we're looking for, fuel conscious. So with your vehicles, if you can rethink like your transit, we talked about this in the last one too, maybe carpooling. Again, small things add up. If you carpool twice a month, that is twice a month that, there are not two cars on the road. That's once a month, right? So kind of interesting. And then I think the biggest one here is reduce, reuse, recycle. So anything you can to essentially reduce your waste on the planet is a great thing to do. Another big way that humans are damaging the planet, damaging all kinds of environments, and this one makes a whole heckin' lot of sense, is the deforestation of rainforest. Now, the rainforest is not the primary area where we get the most oxygen. That's actually algae. Fun fact. But the rainforest is a massive filter for the planet. So all of that carbon dioxide and methane and whatnot, that can filter through the trees of the rainforest, which is a primary area that this happens. And what we see is essentially the rainforest is oxygen scrubbers. So we are essentially going to suffocate ourselves by continuing to tear down our natural filter on this planet, which is just seems like we're kind of shooting ourselves in the foot, which is nuts. Genuinely, this is one of the maps that makes me arguably the saddest. Now, we talked about before that in the last 25 years, 50% of the rainforest have been destroyed. Well, in yellow is where tropical rainforest used to be. And in that teal color is where they currently cover. The yellow is what has been destroyed. And again, guys, I cannot repeat this enough. Once it's gone, it's gone. There's nothing we can do to bring it back. And look how much of the rainforest has already been destroyed. Again, in your lifetime, more than half the rainforest has been destroyed. It is gone forever. So think about that. Maybe in the next 25 years when you guys have kids and they're asking about the rainforest, what are you going to tell them? The environmental impacts of destroying the rainforest have really not a whole lot of limits. The biggest thing is we're reducing biodiversity, which, you remove the environment, the species within that environment don't have a home. It's not like they can just pack up and move to another area. You have now destroyed the place that they live. So the vast majority of those species are going to either move and die, or just die in general. There's not a whole lot of opportunity for those animals or those species to get up and move, let alone the plant species that are just destroyed. They can't get up and move at all. So once again, we have this massive factor that the rainforests are oxygen scrubbers and clean the atmosphere. They help in removing carbon dioxide and other gases from the atmosphere itself, which is going to reduce climate change. So by destroying the rainforest, what we're doing is causing two massive issues. You are basically killing all of this biodiversity in areas of the planet that have the highest biodiversity. You are removing that, and not to mention, you're going to suffocate the rest of the planet because you're removing that filter that cleans our atmosphere. So you're going to see an acceleration of climate change on top of you're suffocating us. I mean, the amount of problems just by destroying the rainforest is kind of countless. There are so many ways that this particular factor of how humans are affecting the planet negatively affects everything on the planet. Sorry, I got a little passionate there. You can tell. This is my big one. This is the one I really care about. And if you really want to watch a movie that's going to make you care even more, watch the movie Fern Gully. And if you've already seen it, then you should know. It's so important to protect the rainforest. So how can we? Make informed daily choices by consuming less single serve packaging, eat sustainable foods, choose to recycle, be responsible with your wood products. Now that sounds very odd. Make sure that you are not buying products that are made from wood that was harvested from the rainforest. You can go plant more trees. Maybe if you have the resources and the time, you want to go volunteer in the rainforest and try to build those habitats back up. That'd be really cool. That's something we can get behind. Go paperless. One of the biggest ones is this fourth one, guys. That is avoiding palm oil products. One of the bigger reasons that the rainforests are being destroyed is to make palm oil. And palm oil is in a ton of things. So a very big thing you could do is put your money where your heart is and not buy anything that has palm oil in it. That tells companies that you don't want it. And if their stocks and their products and their, capitalism essentially tanks with those products, they stop making them. So, just something you can do. Another one that maybe is not so intuitive to think about is reducing your meat consumption. How does that save the rainforest? One of the issues with deforestation in the rainforest is once an area has been destroyed, it is then used for farming, very cheap farming of like cattle. And a lot of that meat is sold in the US. So be conscientious of, where your beef is coming from more specifically. I know that there was an issue with a company, I will not name it, but it rhymes with Hick Honolds, that they were getting their burger meat from the rainforest. They were rainforest cattle, essentially. So, and then the biggest one, guys, is take what you know, use that biological literacy, your scientific literacy that I have been desperately trying to instill in you through the whole semester and educate others on what you know and be passionate about it. I mean, you can hear me right now. You got to be passionate. You got to care, because if you don't care, nothing's going to change. Okay, less of something that we're currently doing that's causing an issue and actually something that is a little bit of a ray of hope. Now, that is to say, we got to talk about it, what happened first and where we are now. So we do have this thing called the ozone. The ozone is essentially a protective layer around the planet that protects life on Earth from the radiation of the sun. It sounds kind of conspiracy theory, but you can think of it like this. It's kind of like a layer of sunscreen that's protecting the planet. That's very important. Now, if we remove the ozone, then we open up all of life on Earth to some detrimental health effects. So it can cause ecosystem damage, it can cause damage to animals, all kinds of things. So it's this UVB intensity that can cause skin cancer. So by removing the ozone layer around the Earth, we are going to increase that risk of developing skin cancer. It can also cause problems with the eyes as well as your immune system. And this doesn't just go for humans, guys. This goes for pretty much every living thing on the planet. So this ozone layer is incredibly important. What's interesting is we started noticing a hole develop in the ozone. And that's really scary, because that means our sunscreen is starting to disappear. And that means that all of those potential problems that I just mentioned could very much so in real time happen. So this hole started to open up in the ozone. We started noticing it in around 1979, and there is still a hole in the ozone. But here's where the good news comes in. We noticed that hole. We realized what was happening, what was causing the ozone layer to open up, to deplete. And we started making changes, big changes, specifically by reducing the production and emission of CFCs, which essentially this is a chemical called chlorofluorocarbons, and it happens with burning of things like, styrofoam, as well as the aerosol in hairsprays. So we noticed that these CFCs were causing this issue with the ozone layer, and we did something about it. And now the ozone is starting to heal itself. That is kind of the power of good science and effective policy making. It's wild that people can't get behind these important things like they did with the ozone layer depletion. So once again, there was a worldwide response to these CFCs causing the ozone to deplete, and you'll notice that very few companies will use that styrofoam, and I don't think CFCs are in hairspray anymore. I could be wrong, but I'm pretty sure that was something that was changed. And again, once that worldwide response happened, everybody banded together and said, okay, no more CFCs. Got it. We start to see that ozone layer start to heal itself. Now, let's talk a little bit more about conservation when it comes to species, because we want to end on a high note. We had the kind of power of worldwide cooperation to start to heal the ozone layer. What else do we do to protect the planet? Well, we have conservation efforts that we can put forward to protect species that are at risk. The problem is, who do we save? Because we can't save everybody. Now, if we were in person, I would ask you guys between this absolutely most adorable baby angel of an Egyptian tortoise hatchling and a bacteria found in soil, if you knew that both of these species were at risk but we could only save one, which one would you save? And what surprises me is the reason you guys tell me you choose one versus the other. We have a soft spot in our heart for that absolutely adorable baby tortoise, right? Because he's so cute. But some of you will give me the answer of the soil bacteria because that probably protects other species too, maybe helps plants. And so you guys end up having this really fantastic connection to what we need to save versus what we want to save. Because again, we have to make choices that can be pretty hard to essentially triage what is happening, and that is this mass extinction event. So, in preserving biodiversity, we can't save everything. However, we do have conservation policies in place. One of them that many of you have talked about in your Save the Species paper is the Endangered Species Act, or ESA. And this is a way to essentially grade how critical a situation is for a species, as well as what conservation efforts need to be put forward to save that species. Is it feasible? Can we do it? How detrimental is it for that species in general? So this should be something that you guys are decently familiar with based on what you have researched when it comes to your species. There are multiple really effective strategies for preserving biodiversity, but the best one and the biggest one is usually landscape conservation. And what we say with landscape conservation is protecting natural areas in mass. So things like our national parks, like Yosemite and Yellowstone, things like that, they are incredibly important natural areas that when we save that entire natural area, we are saving every species in the area. Now, because I like giving a call out to him, he's one of my favorite people in the world, and I probably asked you guys over the semester if you could have dinner or something with anybody, living or dead, who would it be? Mine would be Theodore Roosevelt. I find him to be one of the most fascinating men in U.S. history. He just seems like he'd be a fabulous person to talk to. In fact, in case you didn't know, my cat Ted is named Theodore Roosevelt, and that is his full government name right there. And there's a little picture of him next to President Roosevelt. So what Theodore Roosevelt did, not my cat, the president, was set aside 150 million acres of forestry and land to create 5 national parks. Now, he wasn't the first president to get the ball rolling on national parks, mind you. That was actually, I believe, Abraham Lincoln who set aside land in 1864 that would eventually become Yosemite. Ulysses S. Grant also helped make Yellowstone a park in 1872. But what Theodore Roosevelt did was go down in history as the president who preserved the most land, made the most bills, most policies to preserve as many natural areas in the U.S. as possible. And he is the only president to have done that. He does take the cake with that one. And it was because he loved the United States natural areas so much. He was absolutely obsessed with this country and how beautiful it was, and he wanted to preserve these natural areas, whatever cost it took. When we look at preserving individual species, we have certain titles and descriptions of those titles that describe that preservation of individual species. The first is a flagship species. These species are usually defined as being charismatic, very distinctive, vulnerable, or otherwise appealing. I like to tell you guys, flagship species are sexy. That's right, you heard me. They are sexy species. Now, I don't mean like sexually. They are not sexy in that way, but they're very appealing. Like things like pandas and elephants and gorillas. They are species that you know about, that are appealing because you see them and you feel empathy. You care about them because you've seen them in movies or in media. You've heard about them. You care about them because they're charismatic and usually pretty cute. Some examples include, like I said, the giant panda, a golden lion tamarin. That's that little orange guy in the bottom corner. Isn't he cute? The mountain gorilla, orangutans, and leatherback sea turtles, Indian tiger, and the African elephant. These are all really good examples of a flagship species, a quote-unquote sexy species. The preservation of these species, given their habitat needs, can also, as sort of a side effect, serve to preserve other species as well. So usually the preservation of these guys helps protect other species. Many of you should be pretty familiar with this term, which is a keystone species. Keystone species have a disproportionate effect on the biodiversity of a community. They're kind of like if you've ever played Jenga, they're the bottommost bricks in the tower of the Jenga tower. If you remove them, pull them out, jostle them, the entire tower crumbles. That is a keystone species. They are the key to an environment. Some examples include kelp, California mussels, grizzly bears, beavers, and sea stars. In fact, I think we've talked about sea stars before being a keystone species. But the removal of these species causes massive changes in the composition of species in an ecosystem, usually that community, which can usually lead to the loss of a lot of biodiversity. They are incredibly important. Next is indicator species. These are going to be present in an ecosystem and indicate whether or not the environment is healthy or not. Good example is lichens, which, fun fact, a lichen is not an individual species. It's actually the formation of bacteria and a fungus living together, or fungus or algae. It kind of just depends what type of lichen we're talking about, but it's usually a symbiotic relationship. That's neither here nor there. Just a little fun side note that lichens will indicate air quality within an environment because they're particularly sensitive to sulfur dioxide. So kind of interesting if you see areas where the lichen is dying or doesn't exist. It may not be a particularly healthy area. We do have a fourth preservation species, that is the umbrella species. These are wide-ranging organisms that require large habitats and other resources so that their preservation simultaneously protects numerous other species within that habitat. Some examples are the spotted owl, the coho salmon, red wolf, and spectacled bear. Now, let me kind of reiterate, these guys have such large areas that they need in a habitat that if you protect the species, you have to protect the entire habitat. By doing that, they are kind of more so creating a safe space for everything else living within their habitat, living within that range that they need to survive. They are an umbrella species, very important. Now, many of you kind of went into a lot of uh, conservation with your species in your papers, which I love. I think that's fantastic. A lot of it is easier said than done. So, how can we bring back a species that is on the brink of extinction? Captive breeding programs. A hot topic lately has been the polar bear at the St. Louis Zoo, Collie. He was sent to another zoo so that he could be part of the breeding program, and what I've heard, things have been pretty successful and good for him. Habitat restoration's a big one. Zoos and botanical gardens kind of go hand in hand with that captive breeding programs, but those can also have a lot to do with conservation efforts. Our St. Louis Zoo, kind of along with Collie, has a really fantastic hellbender program where the hellbender, it's called the Ozark hellbender, is a type of salamander that was on the brink of extinction, and our St. Louis Zoo put together a program where they started trying to breed the hellbenders in captivity, and it took years trying to get them to successfully breed, and now it is an incredibly successful program with our zoo. So not only do we have a ton of hellbenders at our zoo, we are also being able to release them into the wild, and they are able to reproduce again in the wild, which is absolutely just amazing. So restoration ecology, using ecological principles to restore degraded habitats to their natural state. But again, easier said than done. And that, my friends, is the end of chapter 18 and the end of this course. Thank you so much for hanging in there with me, and whatever has been happening this semester, thank you so much for your understanding and reaching out if you've reached out. I really do appreciate it, guys. I hope to see you soon, and always, keep in touch no matter what. Always here for you. If you have any questions, let me know. Make sure you're studying for the final exam, and keep watching your email. We will be in touch soon.